Hello, my name is Nnenna Ndukwe, and I'm very excited to present to you today on 5 security best practices for production-ready containers. Before I dive into that, I want to talk a little bit about myself. So I'm a developer advocate and I have a background in software engineering over the past 6 years. I'm an avid reader, I'm a writer, I love content creation through different mediums. I enjoy sharing my fitness journey on social media a lot, and I believe that health and wellness is a super important part in the tech work-life balance. I've been in many industries, but most importantly, the cybersecurity space, and that's been a focus on containers and the overall software supply chain. So, security is important, and we know this on a high level because we as humans, we create things. And when we do, we need to empower ourselves by also protecting it. So, in the context of technology and software, maintaining and improving the security of software that we build is extremely important for the protection of our data and the successful advancement of the things that we develop. But what is container security specifically? It's this concept and process of implementing safety measures into your containerized environments and infrastructure in order to mitigate cyber attacks through code, through security tools that you can utilize and integrate into your code or your entire CI/CD pipeline, your entire software development lifecycle, and the way in which you collaborate on your teams in order to share those best security practices. So, what are the challenges in container security? Well, there are a lot of advancements in the container space and they've been incredible, but it's also pretty challenging. And I think that's why it's important to make sure that the security of our code, and in this case containers, are up to par with our development practices on teams. I think the overall goal here is to empower engineers on teams to deploy more secure containers to production, and we want containers to be smaller, we want them to be faster, and also to be less vulnerable to supply chain attacks. And some of these principles can be outlined in more detail in Secure by Design, which was developed and you can find on Cybersecurity and Infrastructure Security Agency, also known as CISA. So now we're going to go over the 5 container security best practices just to give you a high level of what they are. Looking for ways to improve our Docker files, scanning containers, analyzing those containers, and choosing an optimal base image and hardening containers. So now we're going to take a look at an example Python app, and we're going to see how we can apply each of the 5 security best practices. The first one is looking for ways to improve the Docker file. So this Python Flask app, this implements a very simple REST API. And we could probably replace this application, the framework, the programming language with any other one, but this is just the one that we're going to use for this example. We're going to containerize this application. We're going to choose the best base image for it, scan and analyze the results of the scanned container, and then we're going to see how we can harden it for deployment. And this will cover all of the security improvement tips we'll go through. So this is a Docker file, and this particular file we would consider it adhering to pretty good security posture. It uses an official Python base image. There's a work directory and it's defined in the app. It has a good layer construction to minimize cache invalidation and optimize build performance. Files are copied only as required. We see that a port is exposed and it uses an entry point for proper signal handling. Now we're going to take a closer look at the other things specified in this file and why they're important. So if you do not specify a user in your Docker file, your app could run as root. Here the user is set to nobody, and this is an unprivileged system account, and that is available by default in Debian, Ubuntu, Alpine, Distrolist, and others. The nobody account is intended to run things that don't need any particular special permissions. And it's usually reserved for services so that if they do get compromised, a potential hacker has minimal access and impact to the rest of the system. On the other hand, if your app is running as root, then the potential attacker might have complete access to the container and then possibly has access to tools and utilities that are shipped inside the container that they can use to negatively affect your infrastructure. Next, it's important to choose a version number for your base image. We're still looking at this Docker file. We'll call this pinning. So some tutorials teach people newer to containers to pin their images to the latest tag, but containers are meant to be ephemeral. So that means that you can create them, destroy them, start and reproduce with ease and reliability. Using the latest tag means that there isn't a single source of truth for all of the software components of your container. If your container is using the latest tag, getting whatever the most recently updated version of that base image is, any new revisions that are made to the latest tag that you may or may not be aware of, it can introduce some major bumps of the system and the language you're using, which is likely to introduce some breaking changes. So pinning a specific major and minor version in your Docker file is a trade-off. You're choosing to not automatically receive system upgrades or language improvements and some fixes through updates, but this can give you better control of when and how much you'd like to update the versions. Now that we have a container that has an improved security posture, just taking a look at that Docker file, it's in pretty decent shape, we're going to take a look at what's actually inside the container by scanning it. Scanning your container for vulnerabilities is a huge topic, and it's warranted because it's extremely important for knowing what's inside your containers. And according to Sysdig's 2023 Cloud Native Security and Usage Report, 87% of container images have high or critical vulnerabilities, and 85% of those vulnerabilities actually have a fix available, and those aren't even being used in the containers when they're running. So you can catch these earlier in your software development lifecycle by scanning your containers, but we'll dive more into that in the next slides. Overall, it's important to utilize a tool that can allow you to generate SBOMs as well as a part of this whole scanning process, which is a file that contains all of the documented software components that make up the entirety of your container image. These can be pretty important for organizations that need to show proof of meeting compliance standards based upon your industry. So to be able to trace back to every package, module, and version that that were utilized in order to build and run your software. There's a lot of open source tools out there like Gripe and Trivy. There's Claire that are available for you to utilize as part of your pipeline. And then there's other tools like Calico and Slim and more that have this type of feature. So you can integrate scanning your containers into your DevOps workflow in an automated way so that you're always aware of vulnerabilities that can emerge. And this is a part of the whole continuous monitoring concept. And this is one of the best ways to introduce security into your process. So it's going to help you save time and money on engineering resources and empowers your teams to be able to react effectively to any potential incidents that affect the security of your containers. Now we're going to dig more into what happens once your container has been scanned. So addressing vulnerabilities and understanding what's inside of your container can help you to know what exactly you need to address in order to improve the security of your container. The results of container scanning are detailed risk assessments of your vulnerabilities, the size of your images, and what extra contents are in your container that you might not actually need. So this is key information for some of the next tips we're going to go over, for the last tip that we're going to go over. But this analysis can expose known and unknown vulnerabilities, collect CVE data, and reveal which vulnerabilities are high or critical, and which ones are exploitable. I recently wrote a blog post on reachability analysis, and this breaks down the importance of our vulnerabilities we're seeing exploitable, which parts of your code are most susceptible to exploitation, and which packages are actually running in the code that include any potentially exploitable vulnerabilities. So a lot of this information, it can be exposed when you actually scan your containers for vulnerabilities. It's not just about receiving this data though. It is about what you do about it. Once you have this data, how are you supposed to respond? So taking action is the most important step here in this process for improving container security as it relates to vulnerabilities. And there are available tools that bring this information to light and can help you make some recommendations about where your team can focus your efforts in order to mitigate them. So in most cases, this can be a manual process, of removing vulnerabilities, but and that can be time consuming and costly. In other cases, there are companies like ChainGuard, which provides their own version of images to use that have major vulnerabilities already removed from them, so that you can start to build apps based off of those images. Or companies like Slim, where they have a SaaS platform and a CLI tool for automatically removing some vulnerabilities and taking away some of those challenges from DevOps and DevSecOps folks. The fourth tip here is choosing an optimal base image. So, what does optimal mean in the security sense? Let's dive into that. Kelsey Hightower is known for saying, "No code is the best way to write secure and reliable applications. Write nothing, deploy nowhere." Obviously, this is a testament to how we can only try our best to secure our containers with the tools we have available, but risk is always there despite being preemptive. So, when looking to improve the security posture of your container image, selecting the most ideal base image can help. We're taking a look at two metrics in this decision-making process here, and that's image size and vulnerability counts and their severity levels. So when comparing base image sizes, we're looking at the Python app here and the different base image options that are available. We want to ship only what is necessary to production. What code are you actually going to run and use in production? What is in your container but it's unused? Ship only what your app is required. This is super important because when you ship smaller containers, they're faster to deploy and faster to run because of their smaller size and having less files. Smaller containers are also just less expensive to store and transfer. And specifically as it relates to security, when containers are smaller, this potentially results in fewer overall vulnerabilities, which can reduce the overall attack surface of your container. Of course, the frequency of the presence and the severity of these vulnerabilities here matters. Some vulnerabilities will be more important than the others. Slim.AI actually released a container report, and they analyzed over 100 top public container images, and it reveals that there's an increasing trend in dev, test, QA, and infrastructure tooling being left in production-ready containers. So that's like unused shells and interpreters, tools, utilities that are left inside your container images. And that can be used against your infrastructure, actually, to disrupt your operations if a container is compromised. So here are the results of scanning these different base images we have here for vulnerabilities, so we can assess which one is the best one based on vulnerability count and severity, not image size this time. We can see that Alpine here, the results look pretty good. It has 0 vulnerabilities. That's always great news. Ubuntu is the same size as the official Python image at the bottom that we saw in the previous slide. That was at 137 megabytes. But even though they're the same size, the Ubuntu image only has 24 vulnerabilities and 0 high and critical vulnerabilities. The distroless version is based on Debian 11, and this particular build has 50 vulnerabilities. 3 of them are critical, 7 are high, and the official base image is based on Debian 11. And it's not looking as good as Alpine's, I would say. It's 86 vulnerabilities, and 13 of them are high. So looking at these vulnerability counts and the number of higher critical vulns, that's going to help you determine which base image you think is best to use. And there's other factors that play into selecting the best base image that I'm not covering here, which could include compatibility and the amount of support that some of these base image might have in terms of their community, how often, how frequently are they maintaining this code in order to keep down the number of high or critical vulnerabilities. All of that can play a factor, play a part in the best base image, the optimal base image to choose. But these are the ones that we've highlighted here. And this brings us to the 5th tip, which is making sure that you harden your containers. So Rapid4 describes container hardening as the process of actually removing as many vulnerabilities as possible from your containers once you've scanned your containers for vulnerabilities like we've assessed in the previous slides. They say hardening a container minimizes its attack surface, which makes it more secure. It does not eliminate the attack surface. So that's a very important part to emphasize here, that hardened containers are still likely to have vulnerabilities, but the risk of a breach due to known vulnerabilities is as low as possible. So why is this important? To protect your infrastructure from as many cyber attacks as possible. That is number one. And then also to meet compliance standards that are based on your industry. So here's an example of a container hardening using Slim.AI. Using Slim Toolkit is their open source project that the company was created based off of. And you can also use a Slim SaaS portal that they have and their command line interface tooling, which can help you to automatically harden your containers. And this is great because manual hardening is very tedious. Manually remediating and removing vulnerabilities from your containers is very easy to break things, and that can be just a stressful process. So Slim helps to alleviate that pain point by automatically hardening that for you by running some commands or taking it through the developer platform that they have. And this also produces a container image in the build process that you're able to then ship to production and feel a lot more confident about the security of that container. And the last example here that I'll show you of a container hardening that's out there and available to folks to play around with is ChainGuard. And ChainGuard Images allows you to start with their images actually. So you don't have to even begin to think about the safest image selection process that we discussed earlier. They take care of it for you by removing a lot of the major vulnerabilities in some existing well-known some existing and well-known packages or base images out there. And this is what is going to help you have a really nice fresh start for any type of app that you want to develop and have exist inside of a container to containerize it and then deploy it. And that is all that I have for y'all today. Thank you so much for listening and watching. Feel free to connect with me. I am always on LinkedIn and on Twitter. On Twitter, I go by Nnenna Hacks. And if you want to take a look at some of the resources and references that I mention in this talk, feel free to explore some of these links and do some research. Thank y'all.